So here I am in the middle of Bloomington, Indiana. This is the perfect secret laboratory for building tiny houses. Tiny houses. And cob. Check this out. Cob. Over there, there's a bunch of netting for testing drones, drone robots, to build cob stuff. That's what we're here to check out. We got other videos of the tiny houses that we've already checked out. But it's hard to sneak up on a secret laboratory when the dogs like to bark. So, perfect location. Check out this lab. Oh, I love organized people. I love watching what they're doing. Look at this. All these mason jars full of all the different pieces, parts of things. Oh, hey. Beautiful setup. So check this out.
So we're looking at like vertical silage mixers and all the stuff that gets you up to like 7 tons or 7 yards an hour. So it's just very, a lot of the economies of scale can be applied to cow. And we have to like, look at all of it to make it viable.
Yeah.
But that ground wall I was talking about in specific is down this side.
Oh, look at that.
Nice messy lab right now.
We got, what do we got? Lime plaster on this side.
This is a lime. This is the natural earth. This is here. This is natural earth with like a 75% activated charcoal. I've been doing some re-wetting tests. There's been some running, unfortunately, but
Why did you add the activated charcoal?
What's that?
Why did you add?
I mean, people do it for a bunch of reasons. A different color.
Oh.
But some people will claim like ion kind of stuff. But I just wanted. I bought like a toothpaste mix, so it's very finely ground already. That was after making my own activated charcoal, which I really quieted. Or while buying like actual charcoal.
Activated charcoal.
Just buying. I just wanted to show different colors on this wall. And this is where I'm most excited for our the affordable approach. This is just ground, and then there's a product. We'll grab
straps.
It's called Silox. Exactly already here.
Yeah.
Show the camera. I don't think I've looked at this stuff before or not, but
Silox Adobe water repellent, as opposed to using a cement.
Yeah, so that's like a spray. There's two versions of it. One does water repellent on the exterior. They still recommend 4-foot plus overhangs. And the other one is a interior dust control sealant, which makes this sort of finish super seductive because this is very quick. I probably did this section of wall in less than 10 minutes.
What was your process for application of the wall though? Because a lot of these rocks look not pressed, but like almost cut.
So this is hit with a 4-inch diamond wheel. So it's ground. So it's taking back what would have been this roughness, because this was built in 3 lifts of forms. So you can see the form lifts.
Cob walls.
So once this wall was made, back in
The lime finish.
and that does cut through the aggregate.
Yeah, never heard of someone using that.
I've never seen anyone else do it, but it's very, very fast.
I cut with a saw to, like that's really common in the cut world, is cutting with the saw to level it, but then, okay, so no actual plaster, just...
This one's not plaster, this one's Silox, which I'm not sure if you count it as an oil, but it's a dust control additive from the Southwest. Specific to more like Adobe block. I mean, they would be from Monolithic Adobe, which is the name for cob.
I use a clear milk paint on my rough cob walls that I want to keep that way because it's super cheap and one coat does what 8 coats of linseed oil will do.
Sure.
So
yeah, those walls over there are Real Milk Paint Company.
Yeah.
they're pigmented, but
Right,
makes
right.
sense. I didn't know they made a clear one. But that's
You know,
like the
I just
acid.
make a clear one. Yeah, I
Okay.
just like spoil the milk, rinse off the whey, and blend it up with a little borax and water, and then paint it on, brush it
Dust
on.
control.
It's absolute, and it works. I mean, it actually works better than the Silox.
Yeah, I've never used the Silox. This one's not on. This one hasn't been Silox.
Oh, okay.
Yeah.
That makes more sense.
Yeah, this,
Like,
this is still in the rough.
yeah.
And should we do more of this, it will be done with like a 9-inch wheel, so you'll move quicker.
Yeah.
So you end up with like, I think this sort of treatment has the potential to bridge that gap that currently exists between rammed earth and cob, where rammed earth is heavily used in architectural features,
Yeah.
whereas cob hasn't had that same traction in like Dezeen, Architectural Digest, and so forth. I think this sort of finish could elevate it to something that doesn't feel like the cob of the past. But it's just very a practical reason. I mean, this takes literally like minutes to do a wall section, whereas if you're plastering, like those took, you know,
Hours and
10
hours.
times longer, and the other side took, you know, another 10 times longer because of plaster. I mean, making a the way this is stepped is it's a half earth, half lime mixture against the earth, and then a full lime mixture against that. So you have that like to like binding on the way out, but like making that mitigation in the middle. So just it takes a very long time to get to this finish. I think you quoted me the price actually. You're like, it's around $8. You're like $7.50 to $9, somewhere in there is what you can expect per square foot if you go to
Yeah,
lime finish.
yeah.
Earth is a little cheaper than that, of course, but the ground one is like pennies a square foot. It really makes it like an accessible.
If you got an extra
thing.
space, test the ground with just whitewash.
Like a lime base.
Yeah, just just slapping the lime wash on, because that will seal it, but it'll also breathe. But it also, the lime wash is very forgiving, doesn't crack on you,
Gotcha.
and and you can do extra layers when the kids draw on it or whatever really quick.
Cool.
Super cheap.
What's the ratio on that? Is
So,
that just, like, heavy water to lime, or?
So I do a lime putty and let it sit, and the longer it sits, the better.
Yep.
But then you take that and you stir it up so that it's like skim milk when you put it on.
Sure.
And when it goes on, you're like, what did I just waste my time doing? Because it's like, it feels like it absorbs in and doesn't leave. It just leaves this little splotchy stuff, and you come back 20 minutes later and it's bright white, and you're like, oh. So you do 3 or 4 coats to make sure you cover it.
But that's something. Could you like spray apply that? Is it super thin?
You
or
could.
is it-
It's super thin. Yeah, you could actually spray apply that.
So
But
a lot of our logic here all stems from like that grinding action. It's like all what has a great potential of automation with the equipment that
Yeah.
we're using, and what has a great potential for reducing just labor, period, even if it's done by hand. Because it's like even the plastering is like, the people that helped do this were fairly skilled at plastering. It took a long time. It still needs its final layer because it's still cracking in it.
it's still cracked. Yeah.
Whereas like what you're just describing, a grind plus a lime wash is what like anyone can do.
Right,
It's
right.
Very fast. And I guess that is opposed to the cutting you were talking about getting to level. This one did need a tremendous amount of cutting because it was done in formwork.
Yeah.
The formwork did have a little looseness in it on the first one, so I had to do. I did all like. I don't see the axe, so I did like an axe trim to get it back to close, and then we ground it.
The plastic forms that they're using over in Europe are fantastic.
Yeah, the Cobbage does like a nice aluminum one. I haven't seen the plastic
Yeah.
ones.
So my
I'm enjoying being able to see the aggregate.
Isn't
Yeah.
it really nice? Yeah, I mean, I really do. This is my favorite of these.
composting toilet, good stuff. I think that looks like a nature's head. Is that a nature's head?
Yeah. It's the only ones we use. They're really nice. Easy. And diverted.
Is the ceiling that you're going to put on here though vapor permeable?
Yeah. Everything's got to be vapor open. Code requires 5 or greater permeability. It's preferable to get higher than that, I believe. But yeah, that's the tricky walk. Is I don't know if you guys have opinions on what finishes one of these walls without big overhangs, but that seems like a golden goose in materials research. And one of the things should we go to the next round of the grant, setting up a Earth lab? that'd be a problem that we want to tackle over the next like 36 months, 5 years. Be like, what is that finish that actually is robust? And right now, the best thing I've been able to find is one of the Limeworks. I think it's Limeworks. I might be mixing up which company it is. The sprayed hempcrete, where you can pick up your insulation and your finish. They say you can get it down to like an 8 or 12 inch overhang, whereas everything we've designed right now is 3 to 5 foot. So it's a very different beast if we can cut that back. Because roof becomes very quickly one of your highest cost pieces in the house.
The Terracoat product that I've been testing, the company is dormant right now, unfortunately, but basically they take the solids left over from the palm oil industry.
Okay.
That are basically a toxic waste at the high amounts they generate. They're not toxic wastes, but by the time you have that much of it sitting around,
It's a hazard.
it's a hazard. And they took that and added a 20th of the normal polymerizing agent that you would use to make plastic, so that it's partially polymerizing the oil,
Gotcha.
and you spray it on and it soaks in. We did this up at Dan Bednar's straw bale studio. We sprayed it on the brand new, the newly dry straw bale wall plaster. Just spray on the Terracoat. It soaks in. You come back the next day. You turn on your hose with a full spray nozzle right here, and it all beads up and runs off.
That's awesome.
Yeah.
Do you know if it has enough permeability to be like an effective? Like the cob coat requires like a 5+ permeability.
Yeah, it's definitely breathable.
That's
yeah.
awesome.
But I did some
It's
tests.
sprayable piece for you, so it actually looks like when it's
Yeah.
sealed out. The goal is to spray it in such a fashion that it doesn't cover the aggregate that has been split invisible. And this mix being quarter minus instead of sand, you get a lot of that aggregation variation. Quarter minus is kind of the leftover from making gravel, the gravel industry. So
Less than a quarter of an inch.
yeah,
It's
less
like-
than a quarter of an inch. So it's very, very cheap. It's like a fourth of the cost of sand here, and I mean, you can make the same argument that nothing is non-renewable in those systems, but sand for us is far less non-renewable than a byproduct from an industry.
All of our cob material anymore is the compactable fill
Yeah, I
waste
wish we had that
product.
here.
Oh
I tried
man.
to find something here that's like that, and it's just no.
When you come up, I'll take you to the quarry because it gives you ideas. But it just occurred to me, this would be really great to try to set you up to build the schoolhouse that we're designing right now for a farm.
Sweet.
And
What's the build time?
over the next year or two, we got we want to build something super earth friendly, energy efficient. We built them a straw bale schoolhouse when there was a school on the farm, but the township decided it was less of a farm with a ag education program and more of a schoolhouse with chickens.
Gotcha.
And told them they couldn't use the buildings for the kids to be there, and so that's going through the courts right now. But part of their process is to build a better building, and they're fundraising for it right now.
This is more or less our truth window. A lot
Yeah.
of people that were coming live over the summer to be able to see, what this stuff looks like. And that note on efficiency you were just talking about, we are waiting for Anthony Dente and Sasha Robin's information to come back on the 70-pound mix. It looks like that'll push the R value from this, which is about a 0.22, to something more like a 0.75. In which case we can hit energy code regardless to whether or not, we were talking earlier where maybe there's these charging properties in the first 4 or 6 inches. That stuff aside, to get to code in Indiana, you have to be at like an R13 for masonry, and 21 inches of 0.75 70-pound cob gets us there. So we're starting to get to where like below like grow zone 5 and down, cob in its natural form, if it's lightweight with an additional, the straw essentially, it becomes viable in code compliance structures.
Yeah.
So everything we've looked at has either been that lightweight cob, dual wall system with infill, or exterior hempcrete that kind of follows the cottage and the limeworks lineages.
Yeah.
But both those are, it's kind of expensive to get that much hemp in the U.S.
What makes it lighter weight?
The lighter weight's the higher content of straw to the heavier aggregates. So just a lot more straw. So you're like walking that line where 110-pound cob is code, down to about 60-pound cob is still, they call it cob. The low 60-pound per cubic foot, you're starting to enter this discussion of like, now it's lightweight straw. But
Is it structural still?
Is it structural? And there's a belief that it will stay structural to 70 or 60 pounds per cubic foot, but that's not been tested out entirely yet. Those tests are coming, I think, December.
I'm not familiar with the pouring technique. How does that compare structurally?
Like formwork? I don't honestly know. We only used formwork on this for, we had a demo that we were supposed to do in July, and I just made that demo rapid. But you layer it the same way. You're applying it in there in this, and your lift can get a little bigger than the slope. But I think I observed from doing it in that practice was that our shrinkage rate was a higher.
Yeah.
So we were sitting somewhere near like a 3% instead of like a 1-2. So we lost 2 inches on the top. Coming down. I think we would have lost less had we done like.
Check out the drone, the cob drone. With the claw for grabbing the cob to stick it on the wall.
Because you're using like rods, your mate's more like rainbow at that point. So you are kind of willing to cottage if you want to look at most closely at work, because they use balls. The only thing I know is it's kind of
Cob test walls.
they're doing a cob mix all the time. We don't intend to use one. Like this was a compromise for time, just for us for now.
So
The drone is
working with
much drier, and probably drier than what's comfortable for humans, because you have like a certain capacity of hands to push, so we'll cut shrinkage, probably increase some kind of the active processing properties, and the drone's not limited to the same.
Stickers for targeting.
Much heavier, like I'll show you. It's either very, very early implement test. We've been trying to break these as fast as we can so we can send them back to the lab and get. But we'll just various air actuated tools.
Here's the
to
tools.
shape walls quickly. The intention is like the drone can kind of do, like a plane at a time. So we're trying to come up with like the set of tools that works in its language. But I've been building the cob walls now with using these instead of my hands to kind of get a feel for like what's possible. And you can shape up rather quickly, but there's still a lot of exploration to do for like kneading it together.
Yeah, often on site we'll just, when thumbs get tired, just use sticks.
Yeah. The magic thumb.
The weaving, yeah.
Yeah.
So even when I imagine the drone applying, I imagine these sticky
So
little
the idea
fingers,
of breaking these as fast as you can,
speed.
Yeah.
so that we can see what works. So what's
this is-
working so far?
From these pieces?
Yeah.
Well, what's working is figuring out what needs to be fixed. The next set of tools comes in tomorrow. They've been lofted, so this is a smooth transition from here to here.
Ah, yes.
They're much larger. They're like 6 inches across. The infield pattern has been changed. You can see this like hex pattern that's in there, or it's not hex, but like square stock. So that will be different. We did find from this set that the types of plastic, this one's far, like I couldn't break this one until I like air hammered it into the concrete at a stiff angle for a while. All the other ones kind of like, your highest wear is when it's just off the wall, off of everything, and you're holding the trigger, because this oscillates 3,000 times a minute, so it's just pounding the tool apart. But that's the big takeaway. They all broke in relatively the same place, even this one, but that one had to be like against the concrete. And we can print these solid, or we can print them more open and pour them full epoxy. But we're just trying to get like, a lot of our lab is iteration based. So like what we can knock out in a week, it doesn't have to be right. It just has to exist and go and break and learn and then repeat. The other thing is that all the pins are bending. So all that's been upgraded to the next step up in size, and we may go to like a clevis style pin instead of a through bolt, which will give us that much more metal meat on the shaft. So not only are we getting like an additional strength from upsizing, we're getting additional strength of filling in those what would have been ridges for accepting the nut.
I'd be curious to see how a wooden tool worked. A wooden.
Yeah.
Making the same thing out of wood.
Yeah, there's when we step these up to 6 inches, they take 2 pounds of plastic, which is a roll per tool.
Yeah.
Which is like $100 in plastic per tool. And we're breaking them in 1 to 2 minutes. Like
yeah.
It's very intentional to just break them.
Right.
So we are gonna translate between metal. I can't remember which type of plastic this is. This is a more, it's got a higher ductile nature.
Yeah.
It breaks. It doesn't just snap. It breaks slower. And less likely to break because it can accept more damage before it.
Have you just tried casting one out of JB Weld?
We have not. I mean, this is literally, you're seeing like, I'm embarrassed to even show this. This is like literally.
This is the first iteration. These tools came in Wednesday. I broke as many of them as I could that day, as many as I could justify before we went back to costing. Because right now we're in fundraising mode. Yeah.
It's part of the grant. So most of our time is just sitting in front of spreadsheets, being like, how do we get Cobb to, well, kind of like looking at that ladder of how do we get Cobb to market rate and how do we get Cobb to beat DJ Horton? You know, those are, DJ Horton's $100 a square foot ish. Sometimes they sell for 80 new. So it's like, that's just one of the big housing companies, like one of the $30 billion a year scale. Like everything we think about is like, how do you get Earth to scale? And I know there's two worlds of like, it should all be done by hand, but
no,
deploying this stuff.
These are important. These are important worlds to have.
Yeah. Well, we need better houses, and we need better houses at a price point that is affordable and of materials that aren't declining in themselves and declining the health of the people that are in them. And Earth is a very simple, elegant solution to that problem.
What are these tools doing though? Is this
for these right now? It's just like as the machine's putting on just real rough blobs, it's to get us closer to the shape. And you addressed something earlier that is important, is getting like the magic thumb tool or the sewing nature. Mm-hmm. None of those tools are out here. Those are stuff that like they're in CAD, and we're trying to think of how to like make them. We made a set when I was in school, but more longer, more cylindrical, like going in and like finding those fibers and sewing into the layers before.
And something that can approach it from different angles.
Yeah, these sets do approach from 2 angle sets, but humans can do everything, right?
Yeah, well, and specifically, I'd just be afraid of. Tell me how serious this rule actually is, but when we're teaching people to cob, we're like, stop slapping it.
Yeah. You definitely don't want
you're breaking
that.
So I imagine this pressure.
That's just Oregon cob. If you go back to Welsh cob, they're slapping that stuff all the time with pitchforks. They're just slapping it on. Yeah. So, and they're jiggling it. And our rule is don't jiggle it.
Well, I think
that makes sense with the way the clay bonds.
I think the reality is like we have to be doing. Well, I mean, if it works, it works. But it's also like we need a lab to be doing full scale testing where a wall was done with pitchforks and jiggled, and a wall was done with these and impacted, and a wall was done by hand and just put to bed. Like I love the folk knowledge that's got us where we're at, but I'd love to have the scientific bit that like fills it in and lets us talk to code officials in a way that means we can build in every city in the U.S.
Build and break.
Yeah. So the way like Anthony Dente and the tests that were done out west, like they built full scale walls. They put them on test, strong wall, push the top of it an inch, back an inch, forward 2 inches, back 2 inches, see where it breaks. And it's like you start to pull the science that has been applied to all the concrete materials into cob directly, and we can start to be like, here's a report code official. And it was like, maybe this is 5% less strong than hands, so you have to change a piece of the aggregate to get to that point. But then now a machine can do it in a day instead of a human in a week. Mm-hmm. So it is all about finding those, when you're trying to bring an old material forward, you want to pay attention to everything people know, because that folks all we really have. There's been like a little bit of testing, but like, yeah, knowing that it jiggles, like there's a reason why some of those are jiggling and fail. What is that reason? It's like, I can imagine in my head, kind of like what you are. It's like, oh, the clay is plasticizing. And like, that means aggregates, now there's more clay between it or something, and it shouldn't be there. But you know, it's so many things we can assume that,
Well, and clay is and the site clay is so different each place. Yeah.
Yeah, so a lot of what we've been talking about is central mixing, which I know you're kind of happening now because you get it from a quarry where it's pre-mixed.
Right.
So when you're central mixing, even if you're bringing the material back from the site you're working on to central mix and pull into that system, you can test and you can start to move at scale. The problem with that is you end up with a double shipping cost. Like material comes in, you're mixing it, material goes out. So
But if you
far
can-
better off when you're doing like communities or like,
But if you can bring your lab and your silage
There's
mixer.
regional labs, though, I'm sure.
Yeah. There's regional labs, and there's the Earth Block folks have like lab kits and suitcases. I can't remember which company had that, but it's like $500, comes with an instructional video. Like this is how you do all the basic testing. There are some testing you do need to do that goes to lab, like compression, modulus of rupture, shrinkage. Shrinkage you can do on site. But,
Like our ag extension offices do very comprehensive soil tests.
Oh, sweet.
Heavy metals and all that. Like if they were trained up and given the right equipment to
exactly, it's not
do
complicated
those
science.
mixes, you already have that infrastructure there.
Yeah, so we made these. This is tests that were based on the cob code as it was before. I think they're making an update to it. So shrinkage is over like a 2 feet. It needs to be less than an inch as it comes out of the form. And then the compression blocks, they were 4x4. I think this has been changed too. And then the modulus of rupture, just taken off 6x6 by 1 foot. So this is kind of the example of the test done now.
Yeah.
You're going to meet codes. You got the compression where you smash this guy. You got modulus of rupture. We got the single point in the middle to see when it breaks into pressure, and then the shrinkage. This one, pretty easy to do on site. These two are more, they're lab based. And it's taken us a little bit of time to find people to do these ones.
Yeah.
But we do have
True.
folks lined up for this now in our region. But it's the full scale wall ones that are hard. When you're talking 8 by 8 feet, 4-month drying window, it needs to sit inside at someone's lab that whole time, and it's like $20,000 to test. So, not to mention like the labor of going there and building it in a place that's unfamiliar to you, and dealing with that, like these aren't our soils.
I'm curious why they would require these shapes when the concrete lab tests are all based on the cylinders.
Yeah, well, I think this is moving. This is old. This is like a couple of years ago now. But yes, I think you can make a very strong case for core drilling samples being a more accurate test, especially as you move into the lighter straw mixes, because straw doesn't pack into 4x4 inch forms well. You end up with like weird things happening. Like, you never have straw that was like going all around your piece. It's like it literally is in that wall. But if you were to take a core of this, for example, as you're speaking, like concrete core of this wall, you'd have a pretty good idea of the strength of the rest of the wall.
I've moved almost entirely to working with chopped straw just because it works so much better with mechanical stuff.
Yeah, when you're time mixing.
It's so much more predictable for what it's going to do. So what is this? Was this like sculpted with your machines or just?
No, everything in here is by hand right now. We haven't started building with the machine yet. I guess we haven't got the machine in this chat here. So this is the third iteration of the cob lifting machine. This one's tethered to the ground for electric, so there's no batteries. So it's very much a different beast than people. They think of drones. They're like, can it do it? It's like this thing it can lift 200 pounds. So the capacity is not a problem, and it's got constant power supply. The intention is like, you start with just the pick and place, and hopefully, most likely in those first builds, it will be hiring someone like you yourself, Uncle Mud, or talk to Alex Summerall, or someone that's an expert in this field. So they'll be mixing, the cob will be picked and placed by the machine, and they'll be checked by a human.
Right.
Corrected. And then eventually it will move to where, we're doing sculpting, or what you said, like sewing of the layers, they're depositing, like all the things that people do. There are auxiliaries that the machine can do. We have to use different logic to get there. Pick and place is very similar. It's
I
like,
mean, even having delivery and your first, amount of pressure, then the person on site is coming back for the sewing.
I mean, you're cutting out the
That
two
is
people that
such
support
a-
the placer
Yeah.
right out the gate. So there's a third of the labor is
Yeah.
all you need. And then
Well,
what that does
it's-
mean for us is we can pay more for like a really skilled person.
Yeah.
And we're not relying on like a bunch of
And that
volunteers.
wouldn't even be like. Have you seen that on site? Just the carving with the dollar saw.
I've seen some cutting. I've only seen videos of the cutting though.
Like there might be a way to automate that, but it's actually so easy and cheap. And if someone's paying attention to level, it's like unskilled labor.
Yeah.
Like building that into your automated design process of like that's another human job if need be for now.
Yeah. I think pretty much everything except for pick
it
and
would
place would be a
allow-
human job for right now.
And it would allow the design of what this is used for to have walls that are uneven, which should speed
Yep.
you up, not having to
Yep.
specifically have everything perfect in form.
Yep.
Or if your form is, you're going to cut 2 inches off of that,
Sure.
so it can be a little.
So actually, I wanted to mention that to you for later. So our associate Rodney is building the CNC right now for the ability to level big slabs of wood
Sure.
without somebody having to be there to push it back and forth.
Yep.
Just for this long, boring job of taking the slab and bringing it that next step into being a $10,000 conference table, and that could be tilted on its side and stuck against the wall and forgotten about
Yeah.
while it grinds the wall flat.
Yeah, we in school we had a $80,000 shop saver, so we always had that ability to bring
Yeah.
anything to flat. It didn't matter what you put on that thing, it could do it. But yeah, having that in like a mobile version, there's a lot of call for that. But I do think early on there'll be, us being able to bring in someone skilled
Yeah.
as we move towards scale. Because the goal is like, how do we get more Earth Homes out there? And
I just love the claw.
yeah, that thing's so it's a kind of interesting balance of this was all designed by an ex-NASA engineer, so it's all heavily control based. You're like trying to solve the problem with the machine instead of trying to let the intelligence solve the problem through action and repetition. So right now, as this thing is learning to fly and running and using its tools in this tether pack here, you got, of course, got power, and you got data. Data runs off to a pretty high-end GPU and is, predicting the future and trying to like pick the best route to the future that we want based on it
This
reviewing
is such a learning curve for me.
it's got 3 sets of vision on it. They're looking at the wall, and then there's one watching its tool.
Know that it's doing a good job? Like what a
So
versus bad is? Is it
for
programmed in?
yeah, so for flight, it's like it gets a reward if it's X place, and it's like, am I at the X place? If it's not at X place, it's right at X place. So if it's gets to that spot, then it knows it gets rewards, and it can like kind of remember how it got there and project in the future how what actions might lead to getting there quicker.
Same with like textures and densities and
So everything
Well,
on
getting to quality.
yeah, so texture's a little much harder problem. So I think a lot of that has to be done on the mixer side. So the person who's operating the equipment that mixes the cob needs to be highly educated in what a proper cob mix looks like. So it's not doing that work. That's kind of the supply side of getting cob to scale, which we've learned to lean kind of heavily on the Isle of Cob blogs from the late 2010. I've never gotten a hold of the guy that wrote them, but he used vertical silage mixers to do their mixing, and you're hitting like 7 yards an hour, which is 4 times what you're getting when you're doing the drop method with equipment, something like that.
Yeah.
And then I don't know, an order of magnitude more than when you're tarping it. Which everything we do here is tarped, unless we're doing like a wall of that scale, then we'll do mortar mixers. Renting a 7 horsepower or 9 horsepower mortar mixer.
I have an electric mortar mixer that I really
You've got an
like.
electric one that does
I have an electric mortar mixer. I can fit it in the back of my Prius and take it places. And it can it and one person can feed 2 to 4 cobbers.
Yeah.
And the mix is a lot more uniform than tarping. When you can beat that straw into fiber is when it starts getting really interesting.
How does that compare to like the Bobcat or tractor mixes?
Oh, the Bobcat or tractor mixes aren't as uniform, but they're so much quicker.
Yeah.
The
That's kind of the scale. It's like tarp to mortar, mortar to bobcat, bobcat to silage. From what I've found, mixing stuff. That seems to be
yeah,
really
and the so big tractor with rototiller, and also just using a backhoe excavator in a pit can work pretty darn quick, and also give you putting it on the wall, which is also really nice with the Bobcat. What I'm wondering is where the RoboCob cam is, so that we can watch this do its cool thing.
Get you that. I did want to answer your question. Start on that thread though. How does it know it's doing something right? You know, there's the like flight position, and then kind of when you're talking about how much cob is it holding. So in the chain of the tool mount, you have one joint that lets you go forward and back and side to side. The next step down in that is a sensor that takes weight, tells you how much you're holding. So we have that there. We use similar sensors called strain gauges. We use them up here as well when we're training, and that lets it know if it's pulling too hard on one of its safety connections. I mean, eventually it'll get outside this, but this logic is in a smaller form on there. It's a little easier to see what's happening here, and it's like invisible to your eye. That aluminum bends, and it reads that bend and changing current, and that changing current has a weight associated with it. I mean, it's not naked eye kind of weight association, but that's how we're reading that part of it. Okay. And then the kind of the third step, answering that question in the longer term, is cameras on 3 sides. One that looks into its tools, so you can see where it's kind of like grabbing the earth. And then it's voxel mapping, so it has like, this is what the world should look like. So it sees the wall there digitally before it lays the earth. And then it's laying the earth and then trying to... Within its visual image of the wall. Yeah, it's trying to like correct it to fit that model. And that model is the earth wall, just digitally. That's how you get that. This is outforms. Yeah. So we're trying to be as close to traditional formulas and techniques as what's known as possible. That's why we're not pumping this. A pumped cob is a very different beast than we can say our lineage is thousands of years old, and there's a lot of documented success with it. And the Southwest, it's still, I mean, Adobe's a premium there, and cob is still, its historical form that's in practice in like northern, kind of like the UK Isles and so forth.
So when you're ready, I can give you contact info for my friend. My friend Tim, who was the one who he did a lot of horizontal silage maker cob mixing. Awesome. And
that would be fabulous. I've been working on that problem. Like we've been working supply chain stuff for a long time. And it's things you've said, it's things Cobbage has said, it's things Dente and Sasha Rabin are working into. But yeah, anybody that's mixed with silage mixer, I would love a phone call with.
And he's the only one I know of that I've been able to access who wasn't a volunteer just describing what they saw, but somebody who was actually having to pick the rocks out when he locked it up and things like that.
We called the silage mixer the Pat's company. Made the one that was documented in that blog post from a dozen years ago.
At least.
Kind of discussion.
Yep.
And they had sold one recently to a copper. They couldn't give us their information because privacy. Tell random people random things. But someone else has one actively in the last couple of years, and they are conceivably using it.
Excellent. So, hey, Christina, look interested.
But those machines.
Those
machines require like huge horsepower to run the big ones. It's like a 90 horsepower. We're talking like an upper mid scale.
Or the one with the built-in motor, the built-in engine, and then you still want a skid loader on site. So you got to really have
you're still screening your clay.
The project. But this guy, the Tim that I'm telling you about, we do a podcast every Sunday night, just talking about stuff or bringing somebody in to talk with about what they're doing, and and he did he figured out the automation for straw bale back in, I think, 1996 on an 80,000 square foot straw bale winery. And I quoted it based on having a crew, and while they were at it, figured out the automation so they could make a decent living.
I would love to talk to that human, or if you ever want to ask people to chat.
I think we'll be ready for you. We're preloading the podcast with the ladies of natural building who don't get talked about as much as they should, and then we'll go on to the other stuff we're geeking out about. So like this last month we did one with Valerie Carey, who's doing wood reclamation from modern building projects, from just taking their dumpsters, taking their wood dumpsters, and then making it profitable for them to buy their pre-cut blocking from her. And it's just like, give me your stuff, I'll give it back to you in a more useful form, and you'll pay me and you'll be happy.
Yeah, you're going to save money, I'm going to make money, and stuff doesn't go in the trash.
It doesn't go in the trash. Yes.
So this would all be moving independently. It wouldn't be.
Yeah, it would no longer be. The tether would still be connected to something, but it would be otherwise a drone.
And nobody will stand right here, right? Nobody's going to stand right here for very long, right?
Yeah. As short as possible. The only sensitive stuff is in there, so if you take photos in there, maybe shouldn't be public.
Okay.
But other than that, I don't think there's anything that's
Yeah. Yeah. If they figure it out faster from that than you did, you want to hire them. Huh?
Yeah, we're somewhere in like 3 years.
Yeah.
But we have used the coal to pick stuff up. We haven't done it on board yet, and we have done trained with the claw on it, so it can fly with this machine. And we can look outside too if you want to see any of that training stuff.
Yeah.
Or if you want to nerd about any of this thing. I gotta pee real quick.
Christina, what time is it?
11:03.
I don't care.
Yeah. This is the folks. Terran Robotics. This is Daniel's doctoral thesis that I've been consulting with him.
We do have there's a shed right here. We got that modern. You all need a bathroom.